Now it's the third part. Update the first element with some value and delete the middle element of the list. Okay, so let's try that. Okay, so we have this list 3. Now input. Input what? Enter new value for first element. Okay, so enter new value for first element. Now of course, whatever the user enters, we have to convert it into integer, so that will be typecasting into int. Alright, and now we have to save it. Alright, so that will be number. So whatever number, so it was given x, so I will write x. Okay, so x is equal to int and whatever the user gives us input. Alright, so how do we replace the first element? It's very simple. We just write lst 3 of 0, okay, which is the first element, is equal to x. Alright, and to see if the changes are have actually occurred, we simply print out list 3. Okay, we will also move ahead with the second part because it's going to be a lengthy program, so the more parts we do in a go, it's better. Alright, so what do we learned about over here? That it is mutable. We haven't actually list are, sorry, this is not the correct sign. List are mutable. Okay, we haven't actually seen it as of yet. Alright, but if this works, then we have proved that lists are in fact mutable. Alright, so we also saw it over here because we were appending, right? But then we are editing out, alright, basically mutability by editing. Alright, so we are replacing basically, okay, elements. Alright, so let's try the second one, that is finding the middle element. How do we find the middle element? We find the length of lst3, alright, and whatever is the list, we divide it by 2. Now why do I have this 2 signs instead of 1? That's the integer division. Okay, so whatever is the because we don't want, if it is an odd number, we don't want it to be 0.5. Okay, so what do we want is an integer value. Okay, so we want some index which is an integer index, and that particular index we will replace. Okay, so this is what the mid value, mid index. Alright, so I'll call this as mid. Okay, and this index we have to replace, right? Delete, sorry, not delete, not replace, delete. Okay, so for deleting there is a method called remove. Okay, so lst3 dot remove. Okay, and what do we want to remove? So remove method takes the value, okay, of what has to be removed. Okay, so you can see over here it removes the first occurrence of the value. So we need to give the value, not the index. Okay, so to give the value, we have the index in mid, right? Sorry, in mid we have the index, we don't have the value, so we don't know the value. How do we get the value? It's lst3, which is our list, and mid, which is the index. Okay, so list 3, whatever is the value at this particular index, that value you have to remove, and then simply print the list again. Okay. I guess we'll run till this part and then we'll see the next part. Okay, so let's run this program again. All right, and this time we'll keep it a bit shorter. All right, so 2, 6, 4, 3 elements only. All right, and 3, 5, 1, and 7. Okay, enter. All right. New value for the first element 23. Okay, I should have included space over there, but 23 was added over here, and the middle element. Okay, so the middle element, if you calculate, there were 1, 2, 3, 4, 5, 6, 7. 7 by 2 is 3.5, right? So it removed third element, third index. Okay, and the third index is the fourth element. Okay, third index is the fourth element. All right, so 0, 1, 2, and 3. So this was the third index, and that is the fourth element, which is 4, number 4, and it was removed. Okay, so that is how we remove elements. Okay, now what is the next thing? We want to find the maximum and minimum elements of the list, which is very straightforward. We have max and min functions. Okay, these are generic functions. These are not methods. Okay, so max, let's just print max of LST3. Let's also give something to some label, right? So max is, right? And then we go and write n is, okay, and then comma min LST3. Okay, so now we have the maximum and minimum. I guess we can add some more to this program, because minimum and maximum is just inbuilt functions that are provided, that we are using, right? So we are not doing much over here. It was just to see that we can pass list to such functions that are defined already. Okay, so when we these are mathematical functions, right? So when we pass a list to such mathematical functions, it will return some values based on if it can actually perform those operations. So it can find the maximum and minimum values, so it is returning those values. Then the last thing is to add n names in the existing numbers, and then check if the words Python is present in the list. Okay, so as I said, we can have two ways. Okay, so the first one is the straightforward one, the one which I taught you, right, in this x for x in integer in input, alright, and then we split it and then we save it, alright. That will become a list, and then we add that list. So another is by including a for loop or a while loop. Okay, there are only two loops, so for and while. Okay, we will stick to this method over here. Maybe when we go to other programs, we'll try out those loops. Okay, I don't like those loops because this thing gives us because then if I have to take here, I can simply write spaces and give the input. Okay, and if I mess up one option, I can simply delete it by pressing backspace and type another value. But if I write, the loop, it has to be entered. I have to press on enter, and then I cannot go back. All right, I have to run the program once again, and that is actually the reason why I preferred this type of programming. Okay. Uh, Anyway, I've shown you both the methods. You can use whichever suits you. This one suits me, and I will also type it in the same fashion that I understand. Okay, so the way I understand is, uh, first I'll write an input statement. Okay, the input statement will read enter 3 strings. Okay, enter 3 strings. Then we have to split it. Okay, after having split it, what we have to do is we have to give it to a for loop. Okay, so x for x in, sorry, in, okay, x for x in, and then the input. Now I don't need to convert this into any other data type. It is already uh, string, right? So I need string. Okay, so I have individual elements. What do I want to do now? I want to convert this into a list. So I will enclose this into square brackets, which makes it a list, and then I will assign it a name. All right, and that name is basically n list, because it's a list of names. All right, I'm not really creative that way, so I'll just write n list. Okay, so I have my n list with the name of with the names in it. All right, so I have to append these values into the already existing list 3. All right, so for, I'll have to write for I, or maybe n in n list. Okay, so for each element in this list, what do? I have to append it, right? So where do I have to append it? lst3 dot append, and what do I append? N, simply n. All right, nothing else. Oh, sorry, it's m. It's not m, n. All right. So after having done that, at the end, what do? I simply print my lst3 to check if lst3 has added those 3 strings. And since there is only one thing that is remaining, that is to check if Python is present or not. Okay, so that one we will also involve that one into our program as well. Okay, so now you can see what have we seen over here. We have while implementing this, we will see the heterogeneity. Sorry, there's NPOUS. I hope that is correct. Heterogeneous nature of list. Okay, so it's a heterogeneous data structure, meaning it can hold data of different data types. All right, that we will when we run this, we will see that it is actually true. Here we will see that we can pass it. Sorry, we can pass list to functions. Okay, pass list to generic functions, And now for the following, for the last one, that is to check if Python is present or not. Alright, so that is something which we will see by try catch. Okay, try catch is actually called try except. Okay, so for those who don't have background in programming, those who are new to programming language, alright, try catch is basically when you write your code to check if there is an exception or there is some error that is going to happen. Alright, so do you want to prepare your program for that error? Alright, so in that case you write this try catch or try except. In Python it is called as try except. Okay, so how does that work? You write a try block as you did over here for it was there was a for block. Okay, that is after a colon whatever is there, that it's a block. Okay, then there is this while block. It's a block of statements. Okay, it's a bunch of statements, so block of statements. Then again there's a while block inside which there's an if block and an else block. Okay, of course when I say block, it's a block of statements. Okay, and now we'll write a try block. So try colon. Okay, so try what? So try to run some code. Alright, so what code? So this code, if, alright, if lst3, okay, dot index, alright, if lst dot index, alright, and we have used this for the previously, right, with strings, and if you remember from there, it I said over there that it raises this value error. Okay, and this is what we will catch. Okay, so that is why we are using index. Alright, so I said over there in strings as well that when will you use index and when will you use find. So this is a scenario when you will use index. Okay, so when you want to actually when you estimate that you might encounter some error such as this, the value error, then you might write something like this. Okay, so I want to search what? Python. Let's Python. Okay, so I want to search Python. Okay, I want to find the index of Python. So if it is not present, if it is present, then simply print what? It is present. Alright, and if it is not present, then what? Well, in that case we have the except block. Okay, except block. Alright, in most other languages it is catch block. So basically they throw an exception and they catch an exception. Over here we will accept or catch. Basically in if we are following other terminologies, it is catching that particular error which it throws. In our case it is value error. Okay, so let's write value error. Okay, so we are what are we accepting? We'll use the same terminology. We are accepting value error. It just sounds weird, so I'm used to saying catching. Okay, so catching value error, and what do? We simply print again, that is absent. Okay, that was that, and I guess I included one thing more, that is concatenation of a list. If you want to concatenate a list, you can also do this by simply writing lst 4 equal to LST1 plus LST2. Okay, sorry, LST2. What happened? LST2. Okay, so if I print LST4, I should get all the elements of list 1 and 2 as well. Okay, so this is another way of concatenation. Okay, so okay, and this is try except. All right, so let's run this, and then we will summarize what we learned. All right, so let's clear this screen, run this command again. First even numbers, so 4, 2, 8, 6, I guess that is enough. Then 1, 5, 3, that is also enough. Okay, so first element 32, enter. Okay, after entering 32, we saw till this part, right? Then I guess I should move this a little bit upwards. Okay, oh sorry, there is more to it. It's asking for an input. All right, so after we saw this, the maximum is of course 32, the minimum is 2, and then it is asking for 3 strings. All right, so I'll write my name, I'll write Python because we want Python, and then say XYZ. Okay, because we have to have 3 strings. All right, anyway, it's not necessarily 3 strings because we haven't written anywhere that it will the loop will run only for 3 iterations, but since we have a prompt, then we just wrote the 3. Okay, but anyway, you can see that the heterogeneity of list is established over here, where it combines numerical as well as string data. All right, and then in the except block, try except block, where is that? Here. Okay, when this one runs, it checks and it prints that Python is present. Okay, and then we have our combination. Okay, so 2, 4, 6, 8 and 1, 3, 5. Okay, let's also see the absent value, because otherwise it's wasted, right? Let's run 2, 4, 6, 1, 3, 5, element 12, 21, 3 strings, ni, pi, ji. Okay, that's absent. Okay, so when it catches the value except value error, okay, when it encounters the value error, it gives this particular statement, that is it is absent. All right, and the rest of the code is as it is. All right, so that was an overview of list. Okay, the demonstration of list. Let's quickly recap what we learned. We learned how to take input in a single string. Okay, then how to save it in a list. All right, after doing that, we sorted the list. If it was a numerical, you can also do it with alphabetical. Okay, it is applicable for alphabets as well. Okay, A, L, P, H, A and N, U, M. Okay, so it's not necessarily numbers, it's alphabets and numbers. Okay, so alphabetical order or number order. Then we merge the lists by this quick sort, I guess. Okay, so quick sort algorithm, which basically appends. Now it is very embarrassing that I don't know the name of the algorithm, but I'll take my chances anyway. I know the functioning, right? It's the functioning is right, but I don't. I forgot the name. Okay, so basically we sorted it. We added the sorted elements into the third list and printed it. After doing that, we changed the value of the first element. We deleted the middle element. We found the middle index. We deleted the middle index. Then we use generic functions like max and min to find the maximum and minimum element. Then the heterogeneous nature of list was established by adding strings to it. Then the exception handling, which is done by try except, and I guess there is also finally block. Okay, so we did not actually see that. All right, but finally block is basically used when you want to, yes, there is finally block. Okay, so finally is basically like print and by. Okay, so something that you want to be executed irrespective of what the outcome is. Okay, irrespective of what it was present or absent, by should be executed. Okay, and the reason for including that is because in some cases where you open up files, okay, when you are working with files, okay, so in that cases files cannot be left in some unknown state. So for example, you opened up a file for reading, you cannot have that file open at the end of your program. You have to close that file, otherwise you won't be able to open that file again. Okay, so you always have to close that file. So that code, the closing of file, will come over here. That is the finally block. Okay, so we also have one more flavor of this try except, but that's for the later when we actually go into exception handling. Okay, so for now, try this out, entire thing. Okay, and we'll meet in the next lecture, the next video.